This is part 2 of dimensional analysis. In the last video, we discussed about dimension and dimensional formula of physical quantities. Let's revise that again. Dimensional formula. What is dimensional formula? Expressing any physical quantity in terms of powers of fundamental quantities is known as dimensional formula. Let's see if we have a random physical quantity x. If I can express x in terms of fundamental quantities, what are the fundamental quantities? Length, mass, time. These are enough. Powers of fundamental quantities: L power A, M power B, T power C. If I can express x in terms of powers of these fundamental quantities, that is known as dimensional formula. Let's see a few examples on this. First one, area. Formula of area is length into breadth. Dimension of length is L, capital L power 1, and dimension of breadth is also L power 1 because breadth is also a kind of length. It becomes L power 2. If I can express in terms of mass and time also, then the formula becomes L power 2, M power 0, T power 0 because area doesn't depend on mass and time. Second example, speed or velocity. That is, formula is distance by time. Distance have dimension of L because it comes under length. Time has a dimension T. Finally, it becomes L power 1, T power minus 1. If I include M also, it becomes M power 0 because speed doesn't depend on mass. It depends on length and time only. L power 1, T power minus 1. Third one, acceleration. Formula of acceleration is velocity by time. We already know velocity is L power 1, T power minus 1, M power 0. By T. 1 by T means T power minus 1. So T power minus 1 and again T power minus 1. It becomes T power minus 2. Finally, the formula becomes L power 1, T power minus 2, M power 0. Fourth example, force. What's the formula of force? Mass into acceleration, right? For acceleration, we already know that. This is the dimensional formula of acceleration. So if I include mass also, the power of m becomes 1 because of this mass. So the dimensional formula will become L power 1, T power minus 2, M power 1. Similarly, find for work. Work is force into displacement. I already find for force, that is L power 1, T power minus 2, M power 1. If you include displacement, displacement comes under length, right? So it is L power 1. If you include one more L here, it becomes L power 2. T power minus 2, M power 1. Check this formula. Similarly, you can find for acceleration also. Sorry, for kinetic energy also. Dimensional formula of kinetic energy. What is the formula of kinetic energy? Half mv square, right? Substitute for m. M is m power 1, capital M power 1. For velocity, it is length by time. So L power 1 by T power 1 whole square. Finally, the formula becomes L power 2, M power 1, T power 1, T power minus 2. Okay. Till now, we discussed only dimensional quantities, quantities which have dimensional formulas. We have few quantities which they don't have dimensions. They are known as dimensionless quantities. They are known as dimensionless quantities. Let's see few examples on this. On these dimensionless quantities. These are very important. Dimensionless quantities. Okay. First example, angle. Angle is a dimensionless quantity, but it has units. Unit of angle is radian, but no dimension. Why it has no dimension? Because what's the formula of angle? If you have an arc like this, arc of length L and radius R, this is angle theta, right? Theta is L by R. That's the formula of theta. What is dimension of L? L means length of arc, right? It's length. So L power 1. Dimension of radius is also L power 1. If you simplify this, you finally get L power 0. That means dimensionless, no dimension. All the other quantities M and T are also 0 for angle. So angle is a dimensionless quantity, but it has unit. Unit is radian. Remember this. Angle has unit, but it doesn't have any dimension. Doesn't have any dimension. Second example, solid angle. Omega. Solid angle means angle subtended by an area. Solid angle means angle subtended by an area. If you have an area, circular area like this, subtends an angle omega known as solid angle at the center. Area, and this is radius. The angle subtended by a circular area or any kind of area is known as solid angle. Formula of solid angle is sigma equals to A by R square. Solid angle also have units. Unit is steradian, but no dimension. Remember this. No dimension. Angle and solid angle are similar. Both have units, radian and steradian, but no dimension. Why? Look at this formula, A by R square. Area has dimension of L square. Similarly, R square also L square. If you simplify this, it becomes L power 0, M power 0, T power 0. All are zeros. So, no dimension. Remember these two quantities. Next example. Third example, trigonometric ratios. These trigonometric ratios are also dimensionless. Like this, we have 6 trigonometric ratios. All the 6 trigonometric ratios are dimensionless because theta is dimensionless, right? That we already discussed. So all those 6 trigonometric ratios are dimensionless. And also, whatever inside these trigonometric ratios are also dimensionless other than theta. For example, sine omega t. In place of theta, we have omega t. Omega t is also dimensionless, but omega has dimension, t has dimension separately. Omega has dimension, t also has dimension, but their combination don't have dimension. It's dimensionless, no dimension for the combination. Let's see why. Omega is angular frequency, right? Formula is 2 pi by t. Then the dimensional formula becomes t power minus 1. Similarly for t, dimensional formula is t power 1. Look at this, it's t power minus 1, it's t power 1. If you combine both, omega t becomes t power 0 because this minus 1 and 1 nullify each other. So omega t is dimensionless, no dimension. Similarly for kx also, cos kx, if you have a function like this, whatever inside these trigonometric ratios, that is also dimensionless. Kx is dimensionless. no dimension. But k has dimension, x has dimension separately. Understand? Next example, exponential functions. Whatever inside exponential function is also dimensionless. Fourth example, exponential functions. Whatever inside these exponential functions is also dimensionless. For example, minus e by kt. The whole quantity e by kt is dimensionless. No dimension. But he has dimensions, k has dimension, t has dimension. Individually they have dimensions. The combination is dimensionless. Understand? Remember this. Anything which is inside this exponential function is dimensionless. Remember that. Fifth example, logarithmic functions. Anything inside those logarithmic functions is also dimensionless, as we discussed earlier. Log of something, anything, kt by e, like this. Anything which is inside logarithmic function is dimensionless. As we it's similar to exponential functions. Okay. In the next video, we'll discuss few numericals from previous year IIT JEE paper on this topic.